Hello students, myself RK Mishra. Now we are going to talk about the electrocardiogram part 2 video. In part 1 video you have learned the concepts of electrocardiogram. In previous video lecture you have learned the ECG has three different description. The electrocardiogram, electrocardiograph, electrocardiography. I hope your concept regarding these 3 points is clear. In previous video you have also learned the concepts and principle of electrocardiogram. As you all know, there are two different kinds of ECG commonly used in the medical sector, the standard ECG and detailed ECG. Actually, detailed ECG is not in our syllabus, yet you need to know what about their function. All about their function is clear in previous video lecture, but keep in mind the condition in which we apply multiple leads on the different parts of our body, there will be the detailed ECG. Why there is a need of multiple leads? Many times our body reach to the unconscious stage. At that stage there is a need to take out the measurement of body parts, whether they are live or not. In order to measure the parameters of the live part or dead parts, there is a need to connect the lead with that respective part and the lead further connect to the monitor. Over the monitor you can measure the electrical activities of heart. In this video lecture we are going to talk about the standard ECG. What about the principle of standard and detailed ECG? It was clear in previous video lecture. Now let us talk about what actually consists in ECG. Actually in ECG there is electrocardiograph plates over which there are graph like structure. You can see whether they are in the soft form or in the hard copy form. So first of all let us talk about what actually consists in electrocardiograph. ठीक है, इलेक्ट्रोकार्डियोग्राफ में बेसिकली क्या होता है उसको मैं यहाँ पे डिटेल चेक करेंगे. Actually the graph like structure you can see in normal ECG plate. What actually consists in ECG plates? The normal graph like structure. Listen, the normal graph like structure you can see. Here I have draw the only few lines. Listen, this graph has this is the normal ECG or electrocardiograph. What actually consists this graph? Listen carefully. When you magnify this graph, that is the single box, then you will find the single big box consists 5 little box. 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5. So the box number 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5. It means there are 25 boxes, 25 mini boxes there are in the single box. This is the major box. This represents the major box. Major box. And this little box represents the minor box. Minor box. So this represents the minor box. Actually the single minor box is the single minor box you can see. This is single minor box is measuring about 1 millimeter square area. It means there are 5 little boxes are filled in the major box that occupy the 5 millimeter square area. It means this complete box is actually 5 millimeter square area. Now back to talk about more detail in this box. Actually, this is the major box and in which this is the minor box. The area of minor box is 1 millimeter square and area of major box is 5 millimeter square. It means this is the 5 millimeter square, this is the 5 and each box, that is 1 millimeter, 1 millimeter, 1 millimeter, 1 millimeter. It means each smaller box is the 1 millimeter square and each major box is 5 millimeter square area. Listen. Now back to the next part. The time taken to travel the electrical waves that is generated by the heart. Listen. The heart actually generate an electrical impulses that run in between these boxes. And to the minor box it occupies it can take 0.04 second of the time duration. 0.04 second of the time duration. It means the 0.04 it means the overall 5 boxes it requires 0.04 multiply 5 is equal to 0.2 second of the time duration. It means the electrical wave that generated by heart take 0.02 second. Listen carefully. 0.2 second to travel the one complete box. Listen. The one complete box, this can be traveled by the complete. This is the time duration taken by the heart waves, that is taken by the electrical waves that generated by the heart. Listen. Heart actually, the one cardiac cycle actually taken out 0.8 second. So how many boxes actually taken out by the single cardiac cycle? The 4 boxes, 1, 2, 3, 4. 4 boxes actually required to travel the single wave during the one cardiac cycle. Now back to the how cardiac cycle generated. Listen. Actually the cardiac cycle that generates is first create the P wave. This will first create the P wave and later the Q wave, QRS complex. First it create the P wave and then create the QRS complex and later line will be linear. So here you can see that the P wave, QRS complex and T wave. Now back to the meaning of each wave. This is the P wave, this is QRS complex and this is the T wave. Now back to more detail about P wave, QRS complex and T wave. Listen. The P wave, this is the P wave. This P wave represent the activity of excitement of SA node. This represent the excitement of SA node. This represent the excitement of SA node. And after getting excitement of SA node, this is responsible for atrial systole. So we can say that the P wave it also donates the atrial systole. This represents the atrial systole. This is the P wave and this is generated by the SA node and this is responsible for the atrial systole. And in this way the P wave is responsible to flow the blood from both atrium to the ventricle. Now back to the QRS complex. What does QRS complex means? What is QRS complex? This represents the QRS complex. So what is the meaning of QRS complex? Why? It is more weaker than P wave. This represents the P wave. This is the QRS complex. So what does meaning of the longer peak generated by QRS complex? Listen carefully. The QRS complex actually more bigger because it represents the electrical activity or excitement of AV node. So QRS complex, this represents the excitement of the AV node. This represents the excitement of AV node, and this is responsible for the ventricular systole. This represents the excitement of ventricular systole. What happened after ventricular systole? Listen me carefully. Actually, during ventricular systole, the both ventricles, that is left and right ventricle, start pumping the blood from heart to the different parts of body, which require maximum pressure. Maximum pressure is directly proportional to maximum electrical activity generated by the AV node. So we can say that the AV node required maximum electrical potential to compare than the SA node. Listen carefully. SA node only pump the blood from the both atrium to the ventricle, but the ventricle pump blood from both ventricle to the different parts of body that required maximum pressure. So maximum pressure is directly proportional to the maximum electrical potential. So the peak of QRS complex is greater than the P wave. Listen carefully. This is responsible for the creation of maximum ventricular pressure. Creation of maximum ventricular pressure. So in this way we can say that the QRS complex is greater among all kinds of wave. Now very little wave you can see, very little wave, that is T wave. And what represented by the T wave? Listen, the T wave represent further the atrial diastole and ventricular diastole. It means this represent the T wave. Let us talk about here the T wave. The T wave represent the joint diastole. Joint diastole means when the both atrium and ventricles return back to its original position, there will be the joint diastole. So this represents the joint diastole. So in each case we can say that this is very helpful to measure the electrical activities of heart. Further, the PQRS complex will be as usual. This will be as usual. So how electrical activity done by the heart, and it will be measured over the board. Listen carefully. First the P wave, the QRS complex, then the T wave, then the P wave, QRS complex. So this will be repeated each time. The P wave, QRS complex, the T wave, P wave, QRS complex, the T wave, P wave. Okay. This will be repeated many times as you want to flow it. Listen. On a single monitor, this can be measured, this can be seen through the special equipment. That equipment is known as the electrocardiogram. The next topic is the different kinds of heart disease. Listen carefully. The different kinds of heart disease. Actually, only 4 diseases is in your syllabus, and you need to know what about that disease. First disease is hypertension. The second disease is angina, that is sometimes known as angina pectoris. The third disease is coronary artery disease. That is sometimes known as atherosclerosis. And fourth disease is the heart failure. Only these are actually in your syllabus. Now back to the hypertension. This is sometimes known as the high BP. When the blood pressure raised above the 120 mmHg, the condition is known as high BP. Listen carefully. When the blood pressure down to the below the 80 mmHg, the condition is known as the low BP. Now back to angina pectoris. Actually, the heart muscle feel lack of oxygen in it due to the regular contraction and expanding. There is lackness of oxygen created, so that overall heart feel lack of energy, that problems and the pain appear, that is known as angina pectoris. So the lack of oxygen in heart muscle is called angina pectoris. Now back to the coronary artery disease. As you all know, coronary artery is the important vessels that flow blood from heart to heart. So sometimes due to deposition of the fibrous tissue, calcium and cholesterol, the heart vessels, that is coronary artery, get blocked, which unable to pump the blood from heart to heart, and the heart tissue unable to get the proper amount of blood. That condition is known as coronary artery disease. The heart failure, the condition in which heart unable to flow, unable to pump the blood to the different other direction. Listen carefully. That is known as the heart failure. This is all about matter of today's topic. As you all know, you need to write it very carefully. If you have any problem, then you can recommendedly ask me in comment box. In next video lecture, we will talk about the blood and its related components. Thank you.